All right, well, I want to welcome everyone to HVAC Performance. Let's just measure it. This course is brought to you by the GreenHome Institute. The GreenHome Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the places we live. My name is Brett Little. I will be your moderator today. I'm the program manager here. And like most of our courses, this is approved for multiple continuing education units, including our certified GreenHome professional designation in the energy section, as well as AIA health, welfare, and safety, which may make it applicable to your state-based design or contractor license. As always, we love to do member spotlights. And in this case, our accountant, really exciting, Tim Burgess, your expert bean counter, is now solar powered from a battery to stay off peak during time of use programs. So we're always excited when the folks that we work with are mission aligned and they're getting their energy from solar or working in green homes or you name it. So we want to do a member spotlight on you, so you can sign up to become a member at any time. We'll send you out one of these mugs from sponsored by our TrueTech Tools, and you can get instant access and support our mission. And before we get started, a huge thanks to our top tier sponsor, Build Equinox. Check out the Serve 2. We need smart ventilation. We need to know what the heck is going on in our air these days, especially these days. And also the good thing about them is that when it detects poor air quality, VOCs, CO2, it's going to ventilate only as needed, not overventilate or underventilate like traditional ventilation or dumb ventilation systems, if you will. The other thing is an integrated heat pump system to give instant comfort, keeping that temperature maintained at the highest. It can even work with things like mini splits to completely heat and cool smaller units or tighter homes that are passive house. It's got integrative controls. It's made right here in the United States, right in Urbana, Illinois, manufactured with 100% solar power. So go ahead and check that out over at buildequinox.com. And thanks to our second tier sponsor, Great Lakes Passive House Supplies. They've got frost protected shallow foundation ICFs, air heated radiant floor systems. You can get a hold of them over at totalicf@gmail.com if you're interested in doing a project like that. Now, before I hand it off, just real quick, from a sake of LEED certification and where this session fits into LEED, we're looking at the minimum energy performance category under the energy and atmosphere section on LEED for Homes V4 and even V4.1. And there are three components of the minimum energy performance section. There's making sure that we're not running ducts through building cavities. That's probably a first start. If you haven't gotten there yet, maybe just leave this session and go fix that one first. And then also we're looking at just one Energy Star appliance, and then also complying with Energy Star version 3, not certifying, but complying with Energy Star version 3. And in this case, we're looking specifically at the HVAC contractor checklists and the rater checklists for grading of HVAC systems. So we're going to circle back after the session, back with some more specifics about where this fits in with LEED, but that's kind of the starting point. So with that, I'm going to stop talking, and I'm super excited to hand it off to Ed Janowak here with ACA. And so Ed, please do take it away. Welcome.
All right, I saw the thumbs up, so that means we're off. I'd like to welcome everybody and thank you for hanging out with me today. My name is Ed Janowak, as Brett already said, and I'm the manager of HVACR design with ACCA. I have not been with ACA for that long, but I have been a proponent of their products for a very long time. I'm a heating and air conditioning guy who isn't afraid of math, I guess is a good way to describe it. And I'm a big advocate of installing things the proper way. And when I originally saw this standard, and I'll give a quick shout out to Bill Spohn, and he is the gentleman that put me in touch with Brett to do this Zoomy or podcast, whatever it's called. And I drug my feet. I'm going to say it's probably been, I don't know, 4 months for us to put this together. And it was entirely my fault. I saw the 310 standard. I opened it and saw that it was 100+ pages, and I was intimidated, I guess is the best way to put it. And then finally, I got my act together and I looked at the 310 standard and I chuckled to myself a little bit, simply for the fact that what's in it is not at all difficult for a heating and air conditioning person that is in tune with measuring things that have to do with heating and air conditioning systems. And then I found out that that thick PDF or book was mostly filled with a bunch of tables that are relevant, but you don't need to go through the whole 160 or 190 pages, whatever it is, to use the document. So that's how that works. The organizations that created this joint effort to put this document together are made up of some people that are very sharp people. Sans the one person who happens to be my boss. I don't know how he got on that committee, but somehow Wes did. And I don't know if they made a giant error there or not, but who am I to say? The other part of that is it's not bizarre, but it is kind of, well, I'm going to say it's fitting to have somebody who on the outskirts is familiar with this technology or this process to talk about it, because I think it really lends itself to one of the very first things that Brett shared with me. And that has to do with, there were some people that were showing hesitation to get involved with any of this. And I struggle with that one, simply for the fact that a quality HVAC technician should have zero problems determining the compliance of what's in this document. The rater that is going behind that HVAC contractor, it's not a big reach for them to check for and confirm this compliance. This is my opinion, and my opinion only, but what's really in this standard is what we should be doing anyway. The idea of installing ductwork in a house, and I'll use this for an example, that is leaking its BTUs out into a crawl space or an attic or an unconditioned area, I'll be blunt, it's stupid, right? There's zero reason we should have any, I'm not going to say measurable amount, but a significant measurable amount of conditioned air going outside the house. And again, I'll be less offensive. I'll say it's silly. How's that? One of the analogies I've used over the years is if you have a hydronic system, how many BTUs are leaking out of those distribution systems on a hot water baseboard system? And the answer to that's kind of simple. None, right? Because if we got leakage, we're going around with a mop and a bucket. So we can't have that. So why has there been this thing with leaky ductwork as being essentially acceptable for such a long period of time? It shouldn't be. So it's really that simple. The other part of what we're going to cover in this standard is other things that have to do with air, and we should be measuring that. It's not hard. One of the things that I'll just say it without trying to suck up to anybody. One of the things I was impressed with the standard is they don't have one specific way for you to do a lot of things. They give you the ability to pick your own poison. And I like that about it. So without further ado, let's see what is on the next slide and we'll go from there. So what we're looking at is the workflow. I was exposed to this a while back with some folks that I know that happen to be out in Midwest, someplace where it's cold, maybe in Minneapolis or something like that. And when I looked at it, I was not surprised, I guess is a good way to put it. This is the stuff from an HVAC contractor's point of view that we need to be paying attention to. And I'm going to briefly go over the 5 tests that need to be done or passed. And then we're individually going to break them down and even break them into more individual tests. And I'll give you my 2 cents on all of them. I think it's a pretty good way to put it. The design review, the person that is going to be looking at these designs has to be intimately familiar with doing a load calculation. Not a big deal, but they do, and we're going to talk about that in more detail. Duct leakage tests lends itself to what I was talking about earlier. It's difficult to seal duct systems, but not impossible. It really comes down to the use of resources, both money and materials, making sure that we design systems that lend themselves to being as airtight as possible, and the actual sealing of the ducts. And I don't know if you agree with this number, but I'm going to say a duct system installed that has to meet a leakage standard, it's about a 30% additional cost involved, right? That labor, materials, all that. That's a number I made up a long time ago, and it's a number that I'm going to stick with. And if somebody says, whoa, Ed, that's way off, put it in the chat. Or at the end when we talk about this stuff, I'd like to hear your opinion on that. Next in line, we have blower fan airflow. That's number 3. And measuring airflow is something that is near and dear to my heart. I've been in the HVAC industry since, let's call it 84. So I'm not all that good at math, but I know that's a long time. I worked for a contractor in the very beginning that was pretty big on measuring airflow. So I started in the HVAC world within my first couple of years, where I had an incline manometer and a pitot tube. So measuring static pressure, measuring velocity pressure, things of that nature was something that I've grown up with, if you will. So being able to measure airflow and do it accurately is something I've been very interested in, because I think it's a big deal. We have 4 methods that we're going to discuss, and I'm going to kind of go through the pros and cons of those. And again, it's one of those things, if you're on board and you want to say, yeah, Ed, I'm with you, then speak up. If you're like, no way, Ed, again, I'm all for a quality discussion. Next in line, we have the blower fan watt draw. I'll be blunt. I'm not 100% sure about that number. I can surmise as to we're using a lot of power. It can be an indication that something else isn't right, but I think number 3 is covering that. So I'm going to speak about how we can measure it, and it's not a big deal. But I'd be lying if I said I understood what's going on with number 4 like I do the rest of them. But maybe it'll be fun when we get to that one when we talk about it. The refrigerant charge, non-invasive tests. I have been an advocate of non-invasive tests for a very long time. In fact, I did a blog for our website this past month that spoke about doing those very things, the non-invasive tests. I'm a big advocate of measuring wet bulb temperatures, and we can convert those wet bulb temperatures into enthalpy, which is the amount of heat a sample, or in this case, a pound of air holds, and we can throw some math at it, and we can get a good indication of whether or not that system is doing what it's supposed to or not. And in fact, I'm going to say it's even better than putting a set of gauges on there and measuring to see if our coils are flooded or starved or in the proper condition that we want. In other words, the superheat and subcooling is what it's supposed to be. The weigh-in verification, been a big fan of that for a long time. There's a lot of manufacturers that will still point to that to essentially being the only method that they recommend for charging a piece of equipment. And if you read between the lines there, you figured out kind of quickly that what I was really referencing there is mini splits and that kind of technology. So with that, let's actually start breaking them down. Task 1 is that evaluation of the design. In my mind, that is never how I would describe that. I would say, let's take a look at not only their load calculation, I want to look at their equipment selection. I want to have some insight to their duct design. And I do not believe the 4th book in the design series. And what we're seeing right there is we're talking about the design series. Would be Manual T. And that's the book that discusses grills and registers. And that isn't at the forefront of most people's thought process when it comes to doing a duct design, but grills and registers need to be selected for performance well before they're selected for their appearance. So whenever I get an opportunity to throw that one out there, I take full advantage of it. So we have following the guidance and meeting the tolerance is what our goal is with respects to this. The design series. This is where I get to do one of the things that I absolutely love to do. If you haven't figured it out yet, I'm a pretty strange fella, and I do some stuff that's not the norm, but this was a good one. That is a couple weeks ago on the screen here. That's my daughter. Whenever I get an opportunity to stick her in one of my presentations, I always take full advantage of it. Sitting next to her is her boyfriend. Directly behind her is Alex, one of my coworkers, and the man behind Manual T, shocker, that's what I'm holding up there, is yours truly. Manual D, Manual J, Manual S, the design series. We are loud and proud, so to speak, about those books. And here's some more. We're standing in front of the castle down there in Disney. My kid works down there. So again, whenever I get an opportunity to put her out there, I take advantage of it. But enough of that. Manual J is the book that does the loss and gain on residential structures. In my mind, it's very straightforward. I would like to think that for the average practitioner, that holds true also. Manual S is the book that, and I'm making this one up on the fly, it doesn't stand for shunned, but sometimes it seems like it is. And I almost want to say it's as important as any of, if not more important than any of the other books in the design series. It is a book that aids us in selecting proper equipment. A load calculation gives us a lot of information, but especially when we're talking about air conditioning, the numbers it produces, they need help, and Manual S aids us in that. It's going to tell us what our airflow is supposed to be. D, as you might guess, stands for ducts. So that's going to be our process at which we design a duct system that will allow us to deliver the proper volume so we can deliver the heat or remove the heat. And we're going to do it at a velocity, or how fast the air is traveling through the duct, that's acceptable. It'll allow us to make sure that we cover the space that needs to be covered. And one of the things that when we include Manual T into this discussion, it's the book that gives us the advice to do things like not blow air on people, and where to put our supply outlets, and how to select the coverings that go over the holes, or what I like to call the intentional holes in the duct system, in the space that we're trying to condition, and do it in a way that follows an actual process. And I am no longer surprised at anything in our industry, because I like to say nothing surprises me anymore, because we see a lot of stuff that just makes you shake your head. But we perpetually see things that, my opinion, don't make sense. But when you actually speak to a contractor and ask why they did it the way they did it, it always comes back, or most of the time, it comes back to the same answer. And it's the shrug your shoulders, look at the ground, brush your foot across the carpet, or across the grass. They just don't know. And I think a lot of good information can get shared by doing a proper design. And what this 310 standard helps us with is, it's not only a good design is going to be ensured, but the installation, it's a commissioning process. And if you're a commercial guy, commissioning is pretty commonplace. Residential, not so much. So when we see that commissioning process taking place, it's a solid thing. And I want to reinforce about, it's really not that big of a deal. To to do this stuff properly up front or to make sure that it's done properly on the back end. So that's the design series that can be used when we're dealing with a Energy Star home or a home that's being built and using that 310 standard. When we do these load calcs, when we do these equipment selection or duct design, doing it pen and paper is a thing of the past. There are a plethora, maybe that's an exaggeration. Let's actually look at the slide where they're all listed, but there are a lot of options when it comes to doing a load calculation, your equipment selection, and your duct design. What I would strongly recommend you do, whether you're looking for 310 compliance or not, use an 8th edition recognized program. And that's something that is recognized through ACCA. You can go to the ACCA website. If you go in the search bar and put in powered by ACCA, it will bring you to a screen where it references all of the software programs that are 8th edition recognized for load calcs. And then we have the same thing for duct design. I don't care which one you use. Use an 8th edition program. It's a better math problem, I guess, is the best way I can sum that up.
Ed,
yes, sir.
If you want to go back to that slide too, what do you think about some of these tools here that allow, non-HVAC or even non-raters, maybe more the designers or remodelers, to kind of give them the ability to, start to do some of these calculations and see what they can do. So for example, the one on the bottom of your slide there, and I'll paste a link to it in the chat. I personally use just to feel comfortable when I did my whole home renovation project, right? Like the ducts were already in place. They weren't being moved. So I didn't need to mess with that. Couldn't afford to do that, but just is the sizing of the system correctly? And I, had an energy audit done. I was able to put the information in there. It was very helpful. I'm not an HVAC. What's that?
Cool calc?
Well, yeah, sure. yeah. So yeah. So, I mean, so just that, or, what are you, it seems like there's these tools that are coming out for sort of the non-HVAC, non-rater to utilize. What are your thoughts on that?
I think it is one of the most wonderful things when I watch somebody who's a non-HVAC person doing a load calculation on their house. And you did it. So when we go 5 hours over on this, I'm going to blame it on you. But quick story. I worked over the years on a few utility programs, and I was the compliance officer. I don't even know. I just made that up. For people doing load calcs. And on the regular, I would see homeowners in a situation where the contractor didn't do a calc and they wanted to get a substantial amount of money in an incentive. And the only way they were going to get that is to do a load calc. And there are these individuals out there that are people that I'm sure they had a subscription since they were 5 years old to Popular Mechanics, but they were able to seek out a process to do a load calc on their own.
Right.
And I love sharing this story with contractors that are pushing back hard about, I just use 500 square foot per ton or whatever garbage they use using a rule of thumb. When you can take a homeowner, these processes aren't that difficult. If you can read a tape measure and follow instructions, you can do a load calculation and you can do an accurate one. It just takes somebody with enough desire to want to do it. So some of these methods out there, you're going to spend a couple $1,000 because it does invoicing and material lists and prices, it does all this stuff. And some of them are a couple of bucks per use. If it's an 8th edition program, they all follow the same book to come to the same conclusion. So it's math, and they all have to follow the rules of the math. So it's a great way to do it. And I saw you just popped up MJ8, right? As long as we're using an 8th edition product, it's the way to fly. Can you find some free programs out there that aren't following the 8th edition? And I would do my best to dissuade anybody from doing that to save what could be, and I'm not hawking any product, but CoolCalc, I think, is like $3 a use. So it's not resource heavy out of your pocket as far as that goes. Now, I can't plug a product or mention them without finishing my thought. They do have a methodology where you'd use Google Maps and drop pins from the sky and they guess at windows. Ugh, that makes my eye twitch. Measure your house, input the information, and it's a great way to do it. Anything that incorporates guesses based off of tax maps and things like that, I personally am not a fan of at all. So
Thanks, Ed.
I'll just finish it with that one. Oh, you're welcome. That's one of those topics that this stuff's a big deal. Got to get the math right. And it's not that difficult if somebody really has a desire to do it. So what it comes down to is somebody is going to be responsible for the evaluation of that design. If you look through the standard, I'm going to say of all the tasks that the raters will be responsible for, that's the heaviest lift. There's a lot of individual things that need to be checked to make sure they did it right. And there are instances where it's real simple and it just essentially gets real precise. I'm going to say following the 310 standard is simply an example of how to use the design series and use it in its proper form. So it's good stuff. I'm accused of being a little bit tight in the jockeys at times with how much I want to drill down into this stuff. But at the end of the day, every contractor wants to go do a job and get paid and not have to go back for free. The way we help ourselves avoid going back for free is by doing the math up front. And then the idea of commissioning something is a really good idea. So you got to meet the tolerance. With the this process, you either met the tolerance or you didn't. So it's kind of a pass or fail thing. So if you're not meeting the tolerance, you got to make sure that you meet it. Yes, sir.
Now, when you say tolerance, you're meaning the not being oversized by a certain percentage. What is that number again?
Yeah, well, it depends on the compressor technology. It's going to be 15, 20, or 30%,
right,
according to manual S. But I think this also has there's a component to this process to make sure people aren't cheating. You walk up to a house and you got 60 square foot of glass on your load calc. You got to make sure you got 60 square foot of glass on the front of that house.
Right.
So
right. Yeah.
it's you have to follow the design series, but you also have to make sure that you're legit.
Right.
But to answer your initial question, yeah, you have to make sure that you're following the guidance of the design series.
Thanks.
Task 2. I think there's some people that are familiar with this apparatus that you see in front of you right there. Page 15, it talks about duct leakage. One of the things that I was surprised 5 or 6 years ago when I first saw this, Energy Star and the 310 standard, they actually have a leakage standard that is more relaxed than if you follow the current, which I think current's going to be either 18, or if you're in a market that is adopted the 21 IECC, the standard code is more of a difficult standard to meet than what the 310 standard is. Not bad. We're not talking about giant amounts of leakage in comparison, but there is a difference. So following the prescriptive path is actually more difficult than the performance path. The performance path still allows, over here on the right, you see a duct leakage test being done simultaneous with a blower door test. That's a process where they're measuring leakage to outside, which my opinion only, that's the preferred test. I'm not a big fan of real small amounts of leakage being the finish line or the line in the sand that we have to achieve, when some of that leakage could be going inside the house. But I'm going to stop there because I could talk about that for way too long. And there's just a quick shot of yours truly. I just don't talk about this doing this stuff. I've been at it for quite a while. That right there, I'm kind of proud of. That's a duct blaster that was manufactured well over 20 years ago. And I used it last Friday to demonstrate something else, but yeah, it's something that I still use and does what it's supposed to.
Yeah, and I just want to, jump in here while you're hydrating. And this is clearly a place where it makes this, these tests make sense for the raters, right? The energy raters, because they're the ones lugging around the blower door tests, the duct blaster tests in most cases. And it's actually if you're pursuing a green certification, it's required that it's a third party. It can't actually be the HVAC doing it unless the rater is present. And so, this one has always kind of been part of the normal testing. This isn't really a new one like the ones we're going to be talking about here soon. One thing I do want to point out, though, is we are seeing a significant endemic of duct leakage failures in regards to, trying to hit the Energy Star standard up here, at least in the Midwest. And so it's getting pretty bad out there. And so we're encouraging folks to just take more precautionary measures during the pre-drywall stage, do testing during the pre-drywall stage. Just something I want to warn you about. I mean, I've already seen 2 lead projects, have to fail at the end because of that and have to come back and correct it. So something you want to watch out for.
Yeah, I have some real horror stories with whether it's following the prescriptive path or if it's an Energy Star product where contractors did a lot of work. Drywall was put up. They thought they were doing a good job of sealing and they weren't. And AeroSeal got involved. And the contractors, they didn't completely lose their shirts, but they maybe didn't make the profit on the job that they had initially anticipated. And this is a communication thing. I won't speak for any rater out there, but I don't know of anybody that's doing any work that's being rated that if the contractor contacts the rating agent and says, hey, help me out, come out on one of these and let's make sure that we're doing the first couple right so we don't get into that uncomfortable conversation later. And they're on board because nobody, I like telling people they're wrong and that it's failed because there's something wrong with me, but that's another topic for another day. But who really wants to stand there with the contractor and say, we just checked 12 of these jobs and they all failed? I don't want to be in that situation. I mean, I'd rather do it over the phone because I don't want to get punched in the face. I mean, I'm from Jersey. That's the way they do things around here. So you got to be careful. But obviously that's tongue in cheek. But I do live in Jersey. So it's one of those things that a lot of these problems can be easily avoided just by making sure you're doing what you're supposed to up front. So it's one of those things. This is the way our duct system should be without us being encouraged. Now that's the word I'm going to stick with, encouraged. All right, next we have task 3, and this is right in my wheelhouse. Measuring airflow. I am a huge advocate of measuring airflow. Page 17, it's in the standard. It's going to list 4 different methods of measuring airflow. And it's going to be flow grid, pressure matching, a flow hood, and then a static pressure reading in conjunction with a fan chart or a blower table or a blower performance chart. And I think I could find 3 more ways to describe that, but I'm going to stop there because I don't think I'm impressing anybody. Maybe Chris. Maybe Chris is a little bit impressed, but who knows? Maybe Adam too. I'm just a couple of people that I know. I'm throwing their names out there, and it's kind of fun. Flow grid. A flow grid for many years was my go-to for measuring airflow if I didn't have electric resistance heaters and using the sensible heat formula. That right there is a product that if you want to use it, use it. It's part of the 310 standard. If you don't own one, the only way you're going to be able to purchase that device right there is via eBay, because that one right there is no longer in production and it has been replaced with its newer, better version. And I'm going to back up and show this real quick. You can see that the process here is to take a static pressure reading in the supply, follow the prompts on, this is actually a blower door manometer, and then we're going to insert this grid in place of the filter. The math that's built inside this manometer does a correction factor for the filter versus the flow grid pressure drop, and it gives us a direct read of airflow. A better mousetrap has replaced this product, and we don't have hoses anymore. We have something that Bluetooths to your device. You can tell it to do 2 tasks. One is just an airflow measurement, and one will also tell us if we have issues, where the issues lie, because the prompts will encourage us to determine what the pressure drop across the coil is, if it's a furnace coil combination. It'll also tell us what the pressure drop across our filter is. So it does a little more than the older model with respects to it will aid somebody who isn't as intimate with the process of taking static pressure readings and airflow measurements. And I'm a little partial to this one because I actually had some input in its development, specifically the app that guides it. And I did an airflow class last Friday. And of the 12.5 or so participants, it was unanimous. It was the simplest way to measure airflow. And I had a couple of salespeople who had never measured airflow before, and handing them a device and saying, follow the prompts, 2 to 3 minutes, they had an airflow measurement, which is pretty cool. So if you have a rater who doesn't come from an HVAC background, that's pretty cool. Real accurate results without it being a big deal. All right, next.
Yeah, Ed, I was gonna follow up on that one and put myself in the rater shoes here. This is one where they, we don't see the other raters using that too often, doing that too often, really. And so if they're like thinking, how much is this going to cost me to get that equipment? I mean, what does that usually run?
Well, let's back up for a second. And this is one of the nice things about the older technology being replaced. There's a chance that they already had a blower door manometer,
sure.
because that's part of their thing. But
right.
Let's go under the assumption that they don't. You're looking at $1,500 plus $1,000. So you're looking at $2,500 to get into that. And I'm going to put it the way I feel, just to take an airflow measure. That's pretty steep. You can knock $1,000 off of that with the manometer that would be used in conjunction with the flow plate. So you can get into this completely for $1,500. And if you have a manometer already, we're back to $1,000. So it is a very convenient way to measure airflow. And as time has been our friend, it's become a more economical way.
What about liability? Is there any kind of like, someone's like, I don't want to touch this, or there could be some damage done here?
Literally all we're doing is taking the filter out and reinstalling a filter. The other part of this is the contractor should be taking some sort of measurements to measure their airflow on their own.
Right.
So all we're going to be doing is recreating something that's already been done. And the liability stuff, when we start talking about refrigerant charges and things like that, that's an enormous liability. Or let's be specific about it. It's a scapegoat for contractors that are kind of shady. Any instances that I've been involved with where, as a utility representative, high bill complaints, finding heat pumps that something was wrong, I would go back to the contractor and say, here's the deal. There's something wrong with this piece of equipment. I suspect it's overcharged. And you can do all this through a process that's non-invasive. And immediately they would say, our warranty has been voided because you put gauges on the equipment. And they were usually quite surprised when I said, I measured the airflow, non-invasive. I measured the change in enthalpy with a wet bulb temperature and the supply and the return, did some math, clocked the meter on the house, which we're going to talk about in just a little bit. I know what the operating energy efficiency ratio is that with that piece of equipment, and it's completely non-invasive. And then they knew they were in trouble because they didn't know what I was talking about, which is pretty cool because that always gives you the upper hand. But it's a mathematical process to determine if a piece of equipment is doing what it's supposed to or not. This is that same scenario 20 years later, and it can be done with more sophisticated tools. but a wet bulb temperature is a wet bulb temperature. It's that math hasn't changed in a long time, or at least in my realm, it hasn't. So it's kind of cool, or at least I think it is.
Cool.
So,
Thanks, Ed.
Oh, sure. Pressure matching. This is one that I don't see it being a realistic option compared to the other options unless a couple of very specific things are being met. And it's all about timing. If the test is being done at the finish, then you could easily use this product to measure the airflow through the system. And I'm going to stop with the scheduling stuff, and you can figure that out on your own. So the process to use a duct tester to pressure match, we're going to measure the static pressure in the supply duct, record it. We're going to hook the duct tester up to the system, and we're going to 100% block off the return. So all the air is going to travel now through this fan. We're going to turn the system back on, and we're going to use the power of this fan to match that, hence the term pressure matching. We're going to match that supply operating pressure. Just like our true flow grid has an array of holes in it, essentially what we're doing is a formal traverse to get that airflow measurement. There is a array of tubing inside that fan, which is the same thing. Instead of it being a bunch of holes symmetrically through a square, they're symmetrically through a circle. So we're able to measure the flow through the fan and match the pressure on the supply. And if we're using modern stuff, the gauge that we saw on one of the previous screens, it can give us a direct read. If we're using something that's a little bit more dated, we might have to look it up on the chart. Either way, we're able to do this with equipment that we might already own. So this is my tipping of the hat to the people who wrote this standard. They're not forcing anybody to go out and buy additional stuff. This might not be the quickest way to do it, but it's a very accurate, and I'm not going to call it convenient because it may or may not be convenient, method to measuring airflow. Next is the flow hood. And if someone is going to use a flow hood to measure the airflow through a system, again, this is going to be something, this is my personal opinion. The standard doesn't say you have to do one or the other, but if you're going to be relying on flow hood or bolometers for taking airflow measurements, spend the extra money and get a powered flow hood versus a passive flow hood. The margin of error that you're going to see between these two devices is pretty substantial. I don't want to beat a dead horse, so I'm not going to go into statistics or anything like that, but you can find studies that are not so recent, going back to Lawrence Berkeley 2001-ish, and then a study that was recreated within the last 2 or 3 years by Stephen Rogers, and their margin of error with a passive flow hood are pretty consistent. So nothing wrong with the passive, but when we're measuring the small amounts we see in residential, I would feel a lot more comfortable using something that doesn't have the insertion loss. So again, it's a topic I could talk on for a long time, but I'm going to stop there after I answer Brett's question.
Well, I wanted to think through, a lot of our raters have these to measure the ventilation systems, which is required for LEED and Green Star. We encourage HVAC to do it before the rater gets there, so then we don't have to tell you there's a problem. You don't want that.
No surprises.
Most of them are using passive. So thinking about the ventilation system, like your bath fans and your range hoods, does that the suggestion follows through power? You're going to get a better.
Yeah, a passive flow hood like that's on the screen, not that brand, but that size.
Sure.
It's a random number generator when you're trying to measure 40 CFM.
Okay.
It just doesn't have
so lower or higher is what or doesn't matter?
I don't know.
whatever number
It's-
you're trying to hit.
Yeah.
Yeah.
Yeah. And actually, if you look at the instructions from a lot of manufacturers, when you're talking about a passive flow hood like that,
Yeah.
there's a solid chance they're going to say something to the effect of when you're trying to measure 20 or 30 CFM, you should expect a 50% variance from the true measurement. There's better mousetraps for bathroom fans and kitchen exhaust. They have these things. There's several manufacturers. They have stuff that looks like a wash basin in your sink with a little door, and you use a precision manometer.
Sure.
There's better ways of doing it. Powered flow hood, that's pretty cool to do that. So,
okay. Never heard of one. Thanks.
Yep. Neat stuff. All right. Onwards and upwards. The most common way for a residential contractor, forget about the 310 standard for a second, to estimate airflow on a piece of equipment is with the use of external static pressure. It is a quick and easy way to do it. If we're talking about the 310 standard, a couple of the boxes are checked right off the bat. We're going to have access to the blower data because it's a new install. Everything's going to be clean, which is essential when we're using fan tables to estimate airflow. So all the things that we want to do should be there. The actual process of taking this measurement, not including drilling the holes, should take you about 30 seconds. So if you include drilling the holes, it might take you a few more, maybe it'd take you 60 seconds. This is not a resource-heavy process. Again, a rater's going to have a blower door gauge there because he's probably doing a blower door test, or at least have one available. The 310 standard does require that a precision manometer be used. If for some reason you end up being the person that's required to take these tests and you don't have a blower door gauge, there is a option out there at about a third the price that it's a precision manometer, but it's not made to be used in conjunction with the blower door. It is more of a walk around the house and use it for other stuff. Again, if you're working in houses that have any kind of combustion appliances and you are tasked with doing combustion appliance zone testing, that's the way to fly. Same comparison to the passive flow hood. If you're using a typical manometer that you would be using for duct pressures, stuff that's a 1/10 of an inch-ish or greater, a standard $100 digital manometer, when you start measuring the pressures that start to affect those combustion appliance products, we can end up with another random number generator. So the fact that this is what's required in the standard, again, I think it was a good move. What the original intention was, I don't know. And I think talking about this stuff lends more credibility when I really don't know the process behind what they chose. So it was a good move on their part. Real simple. You can take these readings individually and add them together, or you take them simultaneously, like it's being shown on your screen. You compare it to the blower table from the equipment manufacturer. In this example right here, we have a generic 60K furnace. The model number, this one doesn't have an easy to read model number that shows me what the blower size is. But if I look at my external static pressure, I see numbers. We're not going to have external static pressures down here. They're generally going to be around here. And I'm seeing numbers anywhere averaging around 1,200 CFM. So I'm going to say this is a 3-ton drive in this particular furnace. If we were to set the dip switches on this furnace that contains a constant torque EC motor, at a 0.6 external static pressure, we would be moving 1,035 CFM. So that's how you look at blower data and compare it to a static pressure reading. When we take a static pressure reading, we want to make sure that we're putting the probes in the proper place. Downstream of the filter, prior to the exit to the furnace, would be the proper place on a furnace coil combination. If you're checking fan coils, not a bad idea. Well, the proper way would be downstream of the coil. And right there, I'm going to stop, because one of my problems is I tend to not go off on tangents, but I want to cram too much information into too short of a period of time. So static pressure, real simple way, or even better way to describe external static pressure, quality, simple way to get a good estimate of airflow on a piece of equipment. So on these three methods, flow grid, pressure matching, flow hood, and static pressure, we either meet the tolerance or the tolerance isn't met. There is wiggle room for whether or not your airflow is, and I wanted to say correct, and I don't know if, well, there is. If it's a grade 3, you're too far off base. If it is grade 1 or 2, you'll be graded as such. So this is another one of those scenarios where I should educate myself more on the 310 standard. But I'm going to just flat out say it. I think anyone who is getting graded should strive for everything being grade 1. When we're looking at the difference between grade 1 and grade 2, it shouldn't be more for this airflow test beyond a blower motor setting. It's not that difficult of a standard to meet. If we go back to the beginning with the design process, one of the hard requirements of Manual D is when you design your duct system, our system fan should never start off on high speed. We should always start off on a medium speed. And being able to achieve that grade 1 should be a lot easier if we follow that guidance. I'm not going to say it's 100% possible, but that would be something that I would keep in mind. Task 4, the evaluation of the blower fan watt draw. I'm not going to comment on what the process is or what it's for. I know it's to control how much energy we use with our fan, but if we pass the 2 prior tests or tasks, it shouldn't be an issue, but this makes sense. This might simply be for the process of doing a reality check and making sure nobody's making stuff up. Measuring wattage. My first thought to measure wattage on a piece of equipment, the fan to be precise, is to use a meter that is specifically manufactured with that task in mind. You can buy split core or amp probe style meters that does the power factor math for you. Is a rater going to have that? Probably not. But again, the committee that put the standard together were cognizant of who's actually going to be doing this testing, so they made some other things available. That guy right there is relatively inexpensive, like under 30 bucks compared to the three and a half you'd pay for this guy. And it lends itself to taking one of these measurements as long as an appliance cord was used to wire the furnace, which in many markets is commonplace. Some markets, not so commonplace. So that would be up to the rater and the market he works in. That right there is literally something I just purchased within the last week or so. And it was a $20 item that has the current transformer attached to it. The user, me, is responsible to pick up your voltage, and it's reading real time. Now, I have a 20-year-old, I think it's a Fluke 87, that was extremely expensive and probably 25 years ago. And I hooked it up on the piece of equipment at my own house, and the numbers were virtually identical. So for 20 bucks, the circuitry is available to measure watts, right? And the power factor comes involved there. Not a surprise that inexpensive stuff like this is available because it's available in the plug-in style. So if you don't have the ability to plug in, we have a a very cost-friendly alternative to that. I'm assuming Brett has a question because he just popped up.
Yeah, well, I'm just trying to think, a lot of people now have, especially in these newer homes, green homes, they have these things that are sensing, wattages and draws or kilowatt usage all over their house, right? Or they've got a battery system now that's giving you instant feedback. So
Sure.
is what we're looking at here, where the system's not running, you turn on the blower, you just turn it on, and then so if you were using one of those devices, is that what you'd be looking at, or is there something?
Yeah,
even less
what
than
you're
that?
describing right there would be great for monitoring stuff once
Right.
somebody occupies the house.
Right.
But I doubt any of those technologies would be installed when the rater's there doing his rating. So he would need
Fair
a
enough.
device that gives him the ability to do it. This
I'll
is
tell
another
you-
one of those things where I will defend, for lack of a better term, the rater, because if you go out to the HVAC community, I wouldn't be surprised if there's a lot of contractors that when I start talking about the difference between an inductive load and a resistive load, people aren't picking up what I'm putting down. So
Right.
this is something that a rater shouldn't be intimidated by.
Right.
It is something literally, we're taking a measurement with something that's not a
Right.
big deal.
Now these
And-
wattages come on the equipment, they state it. So how often is it that they're off of what, is the equipment? I mean, I know we're doing this for a reason. Is that because that happens a lot, or?
In the beginning, when I said I really am not 100% sure why they're asking this question,
Right.
that's my answer to your question. I
Right.
don't know.
Yeah.
I would assume that we would see wattage that's higher than anticipated,
Yeah.
but that's going to be along the same lines as a piece of equipment that is using more power because there's an issue with our duct system. So in my mind, this is a reality check. Makes perfect sense.
Right.
And if somebody wants to correct me later and explain it, I'm all ears. I'd say there's a decent chance I'm right, but who knows?
Well,
and I'm not talking to my wife right now, so there's a chance I am right. So that's a whole nother topic for
right.
me.
Ed, before you move on, we are at our time as far as people who want to head out. I understand it's the holiday season. So for those of you who need to get going, you are good to go. You're approved for your CEUs. Don't panic. Thanks for sticking around. You can catch the recording for the rest of anything you might have missed. For those of you who want to stick around, and we're going to get to more of your questions later and finish out this last thought, please do. We'll stick around and for those of you got to go, happy Thanksgiving. So thanks.
Yeah, thanks for hanging out with me. And if you're torn as to stay or to go, I think I'll be done in 5 or 6 minutes. So maybe 8, but I know I'm long-winded sometimes. So that's the way it goes. The process, and somebody commented variable speed blower, high static, higher wattage. That's true. One of the things that we want to be very specific about when we talk about those types of fans is while the amp draw goes up substantially, the wattage doesn't. And I want to say those motors are nothing short of magic, and they're not. It's just the electronically commutating part. They're able to do more work with less energy consumption. And I'm going to stop there. So it's another topic that if I was allowed, I would have you here till 3 o'clock. So I'm not going to do that. The next method at which we can measure our wattage consumption is literally by clocking a meter. So clocking a meter is not something that's difficult. I have seen in these standards in the past where they do some pretty non-traditional things. And sometimes it gives me heartburn and sometimes it doesn't. An example would be, I've seen standards where in lieu of using a flow hood, a garbage bag, and a stopwatch. Well, I laughed at first, and then we tried it, and we found that to be a pretty cool alternative. So it's one of those things that I have to try stuff for myself, because more times than not, when I've tried stuff for myself, I've found some of these alternative options to be pretty handy. In this example right here, using the meter on the side of the house to measure wattage is something I've done, and I'm not exaggerating if I say I've done it 1,000 times, because I have. I spent a lot of time in a previous life measuring efficiency on existing equipment, and work done divided by power consumed. Shut the power off to everything in the house except for the device that's operating. That's how you measure wattage. That's exactly what they're talking about doing here. And it's really just a process of using a stopwatch and watching the meter spin around, and at a specific point, there's a little black mark or the hash mark on the dial that spins. You apply some math and you know wattage. It has to be the older analog style meter, which many markets, that's predominantly what's there. If you have a time of use meter, this may or may not be an option, but it is an accurate way to do things. So I get a warm, fuzzy feeling inside when I see stuff where people are using cardboard and duct tape to do a very sophisticated measurement. I think it's really cool to be standing in the bushes watching a meter spin around to do a very accurate measurement of something. So I'm a heating and air conditioning guy. I mean, we're certified rigologists, if you will. Task 5 is evaluation of the refrigerant charge. On page 35, they give us two options: non-invasive temperature measurements, and then a weigh-in verification. This is something that, again, is pretty straightforward. There's some math involved with it, and it's some accurate math. This is good stuff. You don't need to be putting gauges on stuff. And this is another one of those things that, from my perspective, the rater that's doing the test, do they have to be all in with their knowledge on what they're doing? And the simple answer to that is no. Take some measurements. It's either pass, fail. Leave it up to the HVAC contractor to troubleshoot it if it falls outside the range. It's a good use of resources. The weigh-in verification has to be an option because there are a lot of areas where people are going to work where we might have as small as a 3-month window to actually check the charge on equipment. There's other locations, obviously, it might be an option 12 months out of the year. So you can't keep somebody's money hostage for months at a time because of something, and the weigh-in verification, it's manufacturer approved in most instances, or heck, I'm just going to say all instances. Run with scissors there for a second. Those temperature measurements in the non-invasive portion, real simple to get accurate tools that are available now. I've been using one of these Bluetooth things for a while now, and I kind of feel like George Jetson with regards to the technology that's available to me now, and I feel empowered, right? I feel like a superhero whipping out my phone and looking at the performance of a piece of equipment just by sticking 2 thermometers in a supply and a return. And again, it's non-invasive, measuring some air temperatures, not voiding any warranties or anything like that. So it's as simple as a supply and a return measurement converted into some additional information, and we meet the tolerance. Pretty simple. Or we can use the weigh-in method. So what we're seeing is the 2 different methods for the charge portion of it. And we either meet the tolerance or the tolerance isn't met. This is generally something along the lines of somebody not completing their paperwork or something like that for the most part. Neither of these is a big deal, whether you're a contractor or a rater. With that, oh, go ahead.
I just, wanted to kind of point out these, these pre-charged, these factory charged units. I know I typically see a lot of heat pumps that are like that. Does that give us a workaround to having to do this at all? Do air conditionings units come pre-charged? What are your thoughts on that?
Yeah, and if somebody wanted to do something so that they didn't have to do anything after they did a proper evacuation, which is not part of the standard, but we are always going to encourage that. The manufacturers generally and I'm going to say 95% of the time, what I'm going to say is accurate. They put enough refrigerant in the systems for the indoor and outdoor section and 15 feet of tubing connected. So if we stay there, there's no additional charge added. We're just going to document no additional charge added, and the rater can get a tape measure out, or I'm sure they can look at something and say, yeah, it's 10 or 15 feet. Then we start getting into the, and again, this is a generalization, but it's usually going to be somewhere around 0.3 ounces per foot of connecting tubing. And then we're going to adjust for that. We're going to do that with the scale. So that's the way that process works.
So basically you're saying if you're over 15 feet from the system inside to the outdoor unit, that's where you would be looking at doing this test, right?
Absolutely.
Yeah. Okay.
And I saw Joe is talking about, wait, what about Measure Quick? And again, somebody can correct me if I'm wrong, but I don't believe there's a direct connection between Measure Quick and the 310 standard, or maybe there is. So if using some kind of a process or an app is part of a program that incorporates the 310 standard, that's good stuff. With any kind of process where we're going to geotag the work, somebody can't monkey with the numbers, it's all done via an app process, that's the kind of stuff that's solid. I am suspicious of things where people don't follow the rules. They want to game it, and there are things currently out there where we can make it so it is a way to avoid any monkey business. I'll stop there because I'm going to start. It's not tinfoil hat stuff. I think the reality is it's a shame sometimes what happens, and the occupant ends up paying the price for it. So stuff isn't a big deal. Would transducer probes be considered? No, they would. Whenever you connect, and I'll read the question. We have somebody asking, would transducer probes be considered non-invasive due to no hoses? And the answer to that would be an intrusive or an invasive test. We don't want to take the caps off. We don't want to. And does it happen a lot? No, but does it happen sometimes? Yes. You go to disconnect and the Schrader sticks, and we don't want anybody putting hoses on anything. The next part of that is the rater would have to be 608 certified in order to do that. And I do not believe that there is a requirement for them to hold that certification. So I am going to finish up this thought. This is something that's going to come down the road. I do believe that equipment is going to come empty in the not so distant future, because we are going to be using A2Ls. And again, somebody can in the chat speak up if what I'm saying is incorrect. But the last thing I read showed that these A2L systems are going to come empty or with virtually no refrigerant in them. So the whole weighing in process, the amount of refrigerants that are going to be added on site is going to increase. So I'm getting too far ahead, so I'm going to cut it right there. And with that, if you have any interest in any of the things that I am or have been speaking about with reference to any of the products from the Air Conditioning Contractors of America, it's quite simple to go on the ACA website and start clicking around, find something that you're interested in. There's a plethora of good information that can be found on our website. And last but not least, that's me and my crew. Every time my wife allows me to get out, or I'm not stuck in my basement or on location somewhere, we play a lot of golf. edj@acca.org is my email directly coming into my computer. I'm a person that has the mentality of about a 12-year-old kid, so I'm a big advocate of the use of Snapchat. I know there's a couple of people that are actually on with us today that will attest to my antics at times, and I'm a pretty funny guy, I think. So if you want to check that out, that's a good way to get a hold of me. And other than that, that's everything for my presentation. Brett, are we doing Q&A, or we skipping that because I chewed up so much time?
No, we do have time for Q&A, and I was going to share something here, and I'm getting the unshareable slide as well. So that's great. Let me see if I can get this to work. But in the meantime, just real quick, for those of you,
want me to hit the stop share on my end?
Yeah. Why don't you go ahead and do that? I don't think that's the reason, but anyway,
Okay.
just as a reminder, everyone, from a lead standpoint, I wanted to go over a couple things here. Again, I can't quite share my screen right now, but that's fine. So again, we're looking at that minimum energy performance requirement. And again, we're looking at Energy Star 3 is not required, but you have to comply with all of the checklists, if you will. So let's go ahead and see if we can pull this up here. Not the ideal way, but oh, well, there it is. Okay, and then so what we're looking at is eliminating the design review and looking at eliminating the commissioning agent checklist, and instead switching over to what we talked about here, track B now, under this new 310 standard. So again, everything we were talking about here, for those of you who are energy raters, if you want to be the one, or again, your project team, and we're seeing more of this, are hiring HVAC contractors who don't want anything to do with design, don't want anything to do with modeling, don't want anything to do with commissioning. And it's happening. We're seeing it more. Again, track B here is set up for you as the rater to go through that process. It eliminates those two other checklists. It's built right into the Energy Star checklist that you and the builder are using in the field together. So hopefully you can take a look at this standard, connect with your HERS provider. And if you're a builder or an architect working with a rater, have them check out this session. It'll be free online, and they can go through it and then get more information on how to go through this standard. And they can take it from there and be able to still implement the project if, for whatever reason, the HVAC isn't going to be taking it on, or you want to do it in tandem, so you can just make sure everything's done correctly. So before we get to those questions, just a reminder for those of you watching this in the future, not right now, on demand, take that 10-question quiz with an 80% passing rate. You'll get your CEUs. That way, those of you listening live today here with us right now, give us a break. It's the holidays, but maybe next week, check for certs at Gertenbergcerts.com. You'll get your certificate sent to you that way. Check your spam for that. Mark that as safe. And as always, a huge thanks to our board of directors, all of our members, nearly 200. We're almost there. All of our speakers this year, we had so many speakers, and our top tier sponsors, Mitsubishi, Rheem, Aprilaire, Build Equinox, they're all going to help you build better, hit these standards, and have a better product. So there was a question that came in from one of our members, and good to see you out there, Mark. I don't know, he just kind of wanted to know what your thoughts were if we're looking at some of these passive house modeling softwares in comparison to the accuracy of Manual J. Hey, if you have any thoughts on it.
Yeah, ACA has a book called LLS, or Low Load Homes, or LLH, Low Load Homes. And I would look at that before I looked at Manual J for that. And I want to make sure I say this the right way, so I don't get any grief from my employer at the same time. Manual J is a really good path to follow for a typical house. And I don't think a typical house falls under the definition of a low load home. Right. That's why they wrote a book that addresses it specifically. One of the things that's very difficult about anything to do with load calculations is, and I don't want to use the phrase worst case scenario, but I kind of have to. Some of the grief that I hear is the answers that Manual J, or the math that produces the answers, is the numbers are too big. And that's true sometimes. But when you have a typical house that on a design day, if the difference between partly sunny and sunny is 30% of that gain, you're going to have periods of time where you're going to get a larger gain on that house than exists, and that can't be modeled in software. So it's one of those times where it's not necessarily worst case scenario, but it's done in a way that everything has to be included. It's not a safety factor, but it's what the gain is with specific conditions, and we can't model that. So I've messed around a little bit with the LLH book and some of the other programs, and I've found that most of the numbers that I've seen are very similar. But basically what it comes down to, if we have equipment that's larger than what it needs to be, we lose the ability to mix the air more, because that's what runtime gives us. The biggest concern is going to be dehumidification. We've got to have runtime for our CAC to do, or our heat pump to do the dehumidification. But if you're dealing with a passive house, what's the likelihood that a good passive house design is going to lack ancillary dehumidification? So I don't want to say just size it however you want and throw a dehumidifier at it, but a sharp pencil, more along the lines of traditional HVAC equipment, along with ancillary dehumidification, can do a pretty nice job even on a passive house.
Great. And I don't know if you can speak to what your thoughts are, or your guess really, on the rate of compliance on Freon replacement is.
I'm not 100% sure what you mean by rate of compliance with regard with.
Yeah, I don't know.
Elaborate a little bit.
I don't, and this is a question and from one of our audience members. So if she wants to come up, bring up a little bit more to it, maybe it's, the refrigerant recycling is what I'm thinking of when ACs are being replaced or removed. I mean, that's kind of where that's where my head's going. So
okay, and that I can speak to.
Yeah.
Within the last 2 years or 3 years, I sat through a session from somebody from DC on 608, and they would speak to what they anticipated 20 years ago, and it was a chart, and what they expected was my top hand. And I actually have to kind of, this is the reality. It was nowhere near what they had hoped for. I don't know what they expected, to be honest with you, but as far as, it's terrible. There's just, it's not nearly as good as it could be. The contractors, the better contractors that I deal with, they're still following the rules, and they should be commended at every turn. But the reality is the compliance isn't what it could be. And that's, I think, a fair way for me to say it.
So there was a follow-up, and I think this is more, and I think you were speaking to this, I believe, when you had mentioned now that refrigerant isn't going to come at all. And I think we're talking about some of these newer refrigerants that have less global warming potential. One of our members here, she pointed out, and I appreciate it, that Drawdown has listed our number one culprit for climate change being refrigerants. Actually, whether that's accurate or not, that's what they state. So if people are following the Drawdown model, what is that going to mean for newer refrigerants coming? Do we see them coming here soon? I know Europe kind of gets all the nice stuff.
If you follow the politics of it, the AIM Act was adopted, I think is the proper term, which was ahead of the Kigali Agreement being ratified now.
Yeah.
That being the case doesn't really change anything, because the AIM Act did everything that the Kigali Amendment actually would take care of. So we're not that far away from using refrigerants that have significantly lower GDP. So I'm going to say within the next 3 years, and I'm guessing at that, somebody again can correct me if I'm wrong, we're not that far away from a refrigerant that's more environmentally friendly.
Yeah.
And I won't say better because then I'm going to get hate mail from people that would say, it's not better.
Fair enough. So, you know, so I mean, I mentioned this earlier. We're seeing all these issues, all these duct leakage issues. Should we just give up? Should we just hire our friends? I don't need to say their name, but you know, our friends who can just at the end of the project just blow it right in and fix it. You know, should we just tell the HVAC like, don't worry about it, just put the ducts in and we'll put a contingency plan in, or we'll just put it right into the budget and just get it done, and we don't have to have these debates. We don't have to point out bad news that people are going to scoff at for the next 6 months. And I'm giving you a real world story here of horrors that I have. So
I've been involved with being the guy that has to do the test, and I can't get the duct tester pressure above 5 pascals in the duct. And the guy's waiting for me to say, yeah, you're good. And I'm like, you're no good. And I've seen systems that leak so bad that even the Barrow deal, if you can
right, it's a good point. I mean, sometimes it's just so bad the sealant just blows out, right?
It's real bad. But we shouldn't be installing. I don't care if you're following the prescriptive path or the performance. We shouldn't be installing duct systems that are that bad. We just shouldn't. So I know it's a kick in the crotch to some of the contractors out there, but at the same time, I'm all for setting these standards so they're just at a minimum compliance amount. You know, it's just we can do better. And I like to think that in a lot of markets where this compliance is being required, it gives the better contractors a competitive edge.
Yeah.
That's the way I like to think of it. I did see a question in here where somebody asked something about the guy at Coburn's is saying to do something. Adam, if you're still on, if you're talking about Rick, whatever Rick is saying, I would follow what Rick says because Rick stays up on whatever is going on down there. He's a trainer at a distributor that does the Panhandle to Texas, and they have and I make fun of him and his accent the same way he makes fun of me and mine, but I was very impressed to hear how progressive they were with their code requirements and how many jurisdictions actually enforce it, because that's one of the things that I'm not going to go as far as to say embarrassed, but I'm not pleased with my home state. I'm going to say we probably are easily at less than 50% of the jurisdictions enforce the code. So we have a lot of contractors that simply don't seal ductwork to the extent that it would pass a duct tester test because the municipalities don't require it, and they should. And I know the reasoning behind it for a lot of these areas. It comes down to, well, do they have the personnel that understand it? It's a lot of things, and I'm not throwing shade or placing blame on anybody, but it's a shame because I think as a whole we can do better. And there's nothing bad about trying to save resources by simply doing the minimum or what we should be doing. So I think it's really cool to be around a bunch of like-minded people that share that same desire.
Well, Ed, on that note, really appreciate your time and talking us through all this and helping us show that it's not as scary as it sounds. So
I think it was fun.
Yeah. The one last, just remind, where can people find those resources, especially if there's online versions of some of those manuals you mentioned?
You can, if it's somebody that's doing it for an educational type thing, we have content on acca.org that we share stuff with instructors.
Okay.
As far as the content that is to train contractors, we're we're a nonprofit, but we sell stuff. So I would always encourage contractors to become a member of our organization.
Mm-hmm.
And whether you're a member or not, you have access to any of the trainings that we do. So if you go to the ACCA website and you click on one of the drop downs that talks about education or training, we have webinars and we have live classes. If somebody's interested in what we call the 3-day class, which is Manual J, S, D, and T, the next in-person one is early February, I believe, and it's in Washington, D.C., or technically we're in Alexandria, Virginia, but we're a $10 Uber ride from the Lincoln Memorial. So
Mm-hmm.
you get to do some cool stuff while you're there besides just listening to me drone on about.
Fair enough. Well, Ed, John Aka, thank you so much for taking some time. Have a great holiday.
Oh,
you
you're
as
welcome.
well, everyone else. Take care, stay safe. We'll catch you all next week. So bye-bye.
Yep. Take care, everybody.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.